Good morning, student. Today we are taking some other application based on Gauss theorem. That one is electric field due to. This is third application is electric field due to infinitely charged plane sheet. Okay, so here we consider a charge plane sheet having charge density sigma okay, and for this having charge density sigma, and student, you all know the sigma is given by charge per unit area. Okay, therefore now for calculating electric field due to this charge plane sheet, we consider here a cylindrical Gaussian surface okay, and this cylinder is passing through this charge sheet and containing some charge with it. So this cylinder is behave as a charge source, and electric field due to this cylinder is passing through its flat surfaces like this. Okay, now for this particular charge sheet we need to calculate electric field at electric field. So we consider here first we assume the angle between, specify the angle between area vector and the electric field. We have this is electric field and the area vector for the flat surface is in the direction of electric field. We are using this ds. Okay, and for this surface this is electric field and this is area vector ds, and for the curved surface the electric field is again in the same direction, but the area vector is perpendicular to the electric field vector, that is this, with angle of 90 degree. So we specify the angle for each surface of this, that is, this is surface S1, this is surface S2, and this is surface S3. It is clear, student? Now we specifying the angle theta 3 is 0 degree with E and ds theta 1. This is theta 3 is 0 degree for vector E and ds, and theta 2 is 90 degree between E and ds. Here we now specified the angle for each case or each surface. Okay, now we are stating some concept about these conditions. Consider infinitely charge sheet of charge density sigma of charge density sigma now let a cylindrical Gaussian surface Gaussian surface passing through this charge sheet so that the surface Gaussian surface is considered as charge source. We need to find electric field due to given sheet. Therefore, total flux passing through therefore okay ये हो गया, therefore given sheet electric field at every point is equal and angle between E and DS for flat surface is 0 degree and curved surface (90°). Therefore, flux passing through the fluid surface vector E dot ds, which is considered for surface 1, E ds cos theta 1 plus second surface E ds cos theta 2 and plus for the third surface E ds cos theta 3. Okay student, now we are putting the values of angle theta. We are getting closed surface integral E dot ds equal to, for surface 1 E S1 ds cos 0 degree plus E S2 ds cos 90 degree, and for surface 3 E ds cos 0 degree. Okay student, now we are getting the values E ds plus 0 plus E ds for S3 and S1. Therefore we add these two values, 2E ds. Now student, this is the part which enclosed with this Gaussian surface of the given sheet is as a spherical form. So we are using this value total area 2EA. This is equation first. Now we need to consider the charge enclosed. Therefore total charge enclosed by the surface surface is sigma is q, which is given by q is equal to sigma a. This is equation second. Therefore, okay, student copy to this point, then we go to the complete this derivation. Okay, now we are using to read this portion to completing. Now we have, according to Gauss law, applying apply Gauss's law, we are getting integration vector E dot ds is equal to q upon epsilon naught, and this q has value sigma a upon epsilon naught. But we have from equation 1 the value of EDS is integration EDS is 2AE. So we using this value 2EA is equal to sigma A upon epsilon naught. So student, here this A cancel by this A because for the same surface. So we get the value of electric field due to the infinitely charged plane sheet is sigma upon 2 epsilon naught. Okay, now student, it is one thing is very important to notice here. This formula of electric field due to this charge surface is independent by the distance. Okay, therefore the value of electric field due to this kind of surface is not depend upon the distance. It is exactly the same whatever the distance we are using for this surface. So we can write this expression of this expression of electric field is independent by distance. That is electric field is equal whatever is the distance distance due to infinitely charged plane sheet. Okay, student. So complete this. Now we are taking some special cases for these when we are using in place of one seat two seats. Okay. Okay, student. We have two charged plane seats as we take earlier. We all know the electric field due to first seat E1 या हम इसे प्लेन सीट A बोल देते हैं. EA is sigma upon 2 epsilon naught or sigma A upon 2 epsilon naught, and the seat B is sigma B. Sigma A is the sigma A, and this is sigma B upon 2 epsilon naught. It is clear. Now for these two plates the electric field can be calculated at 3 points. One left to the plate A here, one right to the plate B here, and one in between the two plates. Okay. Now we find the condition. Electric field due to this plate A at point this. This is EA, student. Okay. And electric field due to this second plate, again a repelling electric field, that is electric field EB. It is clear, and both the fields in the same direction. So the total field at point P1, it is taken as P1, it is taken as P3, and it is taken as P2. Okay. Now the total electric field due to the first case is total electric field at P1 by plate A and plate B is what we get? We get total electric field at P1 is equal to EA plus EB. It is clear, student? Therefore, when we putting these values, sigma A upon 2 epsilon naught plus sigma B upon 2 epsilon naught. We are getting the result at electric field at P1 is 2 sigma A plus sigma B. Oh, 1 minute. Sigma A plus sigma B upon 2 epsilon naught. It is clear? This. Now we are getting the result is this at point P. Similarly, we are observing here the electric field due to the plate A on point P. This is in the direction of right, electric field A, and due to the plate B, it is EB in the same direction. So these two are also add up. Now, second case is total electric field at P2 is EP2 is equal to sigma A plus sigma B upon 2 epsilon naught. Again the same. Now we are calculating the electric field at P3. Okay. Now electric field at P3, we are finding here the electric field at point P3 due to plate A is this, and due to plate B so we are finding, student, the electric field are in opposite direction. So in third case, electric field at P3 is EP3 equal to sigma A plus 2 epsilon naught and minus sigma B upon 2 epsilon naught. So we are getting the electric field at P3 is equal to sigma A minus sigma B upon 2 epsilon naught. Okay, this is the condition. Now we are taking some special cases. Those are केस 1, इसको हम केस 1 बोल देते हैं स्टूडेंट. केस 1, this one is case 2 and this one is case 3. Okay, now what we find in case 1, if sigma A equal to sigma B equal to sigma, therefore EP1 is equal to अभी हम इसको टोटली केस 1 है ये स्टूडेंट. ओके, ये टोटल केस 1 है. P1, what we get, sigma A and sigma B is this, and we have the result sigma A plus sigma B upon 2 epsilon naught. It is clear, student? Now what we get? Sigma plus sigma upon 2 epsilon naught, and 2 sigmas are add up, and we are getting the result 2 sigma upon 2 epsilon naught. Okay, so these two cancel, we are getting the result sigma upon epsilon naught. Therefore we are having the value PE1 is equal to sigma upon epsilon naught, and this is also equal to the value of PE2. So this value is also for E1 and E2. केस को याद रखिए स्टूडेंट, दिस इज इक्वल वैल्यूज. ओके, एंड फॉर द थर्ड केस, ये पहला कंडीशन, और दूसरा हमारे पास क्या वैल्यू है फॉर E3, दैट इज सिग्मा A माइनस सिग्मा B अपॉन 2 epsilon naught, and we have the result sigma. So sigma minus sigma upon 2 epsilon naught, we are getting the result at the center between the two plates. E3 is equal to 0. This is first case, student. Okay, just copy it. Similarly, you are using the cases when sigma A is positive and sigma B is negative. Case 2 हो जाएगा, and you are getting the result for PE1. PE1 is 0, PE2 is also 0 because the result is same, but at the center is 2. E is equal to, I am finding for you this, just copy this. Done. Now see, case 2. Case 2 where sigma A is sigma and sigma B is minus sigma. Okay, now what we get here, EP1, we have the result sigma A plus sigma B upon 2 epsilon naught, and we have the value sigma A is equal to sigma, and plus sigma B is minus sigma upon 2 epsilon naught. What we get, student, we are getting this result P1 is equal to 0, and because this is the same value as point P2, so we are getting this result, and at center PE3, that is sigma A minus sigma B upon 2 epsilon naught. When we are putting these value of sigma, we are getting sigma minus sigma upon 2 epsilon naught, and for PE3 is sigma plus sigma upon 2 epsilon naught. We are getting the result is 2 sigma upon 2 epsilon naught, and for PE3 we getting sigma upon epsilon naught. This is a very most important derivation. It is asked by every time in the board exam. Copy this. Okay, student, we are stopping today's lecture.